Space is the universe's cruelest roller coaster of hot and cold. With no atmosphere to buffer, temperatures don't slide politely. They whip like a toddler's mood when you take away their iPad. Step into sunlight and surfaces blaze at 250 degrees Fahrenheit, 121 degrees Celsius, pizza oven hot. One step into shadow and it plummets to negative 250 degrees Fahrenheit, negative 157 degrees Celsius, colder than your ex's heart. On the moon, one boot could be sizzling bacon while the other freezes like a popsicle. A human body? Your skin cooks in seconds, blood vessels rupture, and sweat is useless. There's no air to evaporate it. Your eyes? Either boil or freeze depending on which way you're facing. Disaster buffet. Without protection, you'd black out in under 15 seconds and die within minutes. Burned, frozen, suffocated, and depressurized all at once. Space is the worst Airbnb ever. No heating, no oxygen, no refunds. But if this is just the weather, what happens when you face the raw vacuum itself? Temperature was bad. Now let's crank up the nightmare. The vacuum of space is not just no air, it's no pressure. And your body is basically a pressure-loving sack of fluids. Remove the pressure and things get ugly fast. Within 10 seconds, you're unconscious. Oxygen in your blood vanishes like your phone battery at 1%. Then comes ebulism. Fluids in your skin and blood boil at body temperature. You puff up nearly double, but skin elasticity saves you from full balloon animal mode. Instead, blood vessels rupture, saliva boils, and if you forgot to exhale, your lungs pop like bubble wrap. In about 90 seconds, your heart stops. From the outside, you'd look like a bloated, boiling, freezing corpse depending on whether you're in sun or shade. Basically, the universe turns you into both a warning sign and a very ugly statue. And just when you think being an inflating corpse is the worst fate, what happens when something slams into you mid-float? Space debris sounds harmless, like glitter in zero-G. In reality, it's invisible bullets at Mach 25. Earth's orbit is littered with dead satellites, rocket parts, even flecks of paint, all screaming at 17,500 miles per hour. A grain of sand becomes a sniper round. A 1mm fragment can punch through metal. Through a spacesuit, that's instant decompression and instant astronaut smoothing. Inside a spacecraft, it's worse. Debris punctures the hull, air rushes out, people and equipment get dragged toward the hole, and shrapnel ricochets everywhere. Death by cosmic blender. And you can't dodge it. Radar barely tracks the tiny pieces. By the time you know it's there, you're gone. But what if the bullets are smaller still? So tiny, you'll never see them coming. If space debris is a shotgun, micrometeoroids are a sandblaster. These dust-sized particles zip through space at 10 to 70 kilometers per second. That's faster than bullets times 100. They're leftovers from comets and the early solar system, and they pierce metal and glass like tissue paper. A direct hit to an astronaut, instant fatal trauma. Even if it misses you, it can shred a spacecraft interior into a ricochet nightmare. And unlike big debris, these are undetectable. You don't dodge them, you don't see them, you just suddenly have a hole where your chest used to be. And while those are tiny assassins, the sun itself likes to launch its own full-blown nukes. Solar flares are the sun's temper tantrums. They blast out X-rays, UV light, and swarms of high-energy particles. Sometimes they toss a coronal mass ejection too. Billions of tons of plasma hurled like cosmic confetti. Those protons don't just bounce off, they dive into your body, ionizing cells and shredding DNA. Within hours, you'd feel nausea, vomiting, and fatigue. Stay exposed longer and your bone marrow shuts down, organs fail, and your nervous system collapses. Burned on the outside, fried on the inside, the sun turns you into a radiation casserole. But while solar flares are bad, they're just the local hazard. What about the radiation storm that never stops coming from the entire galaxy? Cosmic radiation is the endless drizzle of death from distant stars, black holes, and supernovae. On Earth, our magnetic field filters most of it. Step outside that shield, say, on a Mars mission, and you're soaking in it non-stop. These particles smash into atoms, creating secondary radiation inside your body. DNA mutates, cells die, cancer risk skyrockets. Acute exposure brings vomiting, bleeding, and immune collapse. Chronic exposure quietly shortens your life. Even your brain gets microwaved into cognitive decline. And shielding doesn't fix it. Cosmic rays seep right through. The universe isn't just trying to kill you fast, it's also patient enough to kill you slow. But if radiation drizzle is bad, what happens when you're hit by the full sledgehammer? Cosmic rays are the turbocharged cousins of radiation, particles born in exploding stars and colliding black holes. They fly at nearly light speed, punching through spacecraft walls like cardboard. One ray smashing into you triggers a cascade of secondary particles, ricocheting through organs like a cue ball, exploding into 1,000 pool balls. DNA snaps, membranes rupture, and tissues dissolve in a chain reaction. High doses collapse bone marrow, kill blood cells, and shred your brain into seizures or coma. And here's the hopeless part. No shield stops them. But if invisible assassins are terrifying, what about rogue giants wandering space with the power to knock Earth itself off course? Rogue planets are worlds kicked out of their solar systems. Rogue stars are suns gone solo. Both drift aimlessly, wrecking whatever crosses their path. If one wandered into our neighborhood, gravity alone could wreck the solar system. Earth might get flung outward into frozen dark, collapsing ecosystems and suffocating humanity. A rogue star is worse. It could hijack planets, strip atmospheres, or fry Earth outright. They're not snipers. They're wrecking balls, casually rearranging solar systems. But what happens when not just one object, but entire galaxies smash together? When galaxies collide, billions of stars and gas clouds slam together under gravity's pull. Stars rarely crash, but gas clouds do, heating to millions of degrees and turning into X-ray ovens. Step near one and you're cooked from the inside out. Meanwhile, supermassive black holes at the centers switch on as quasars, blasting radiation jets thousands of light years long. If Earth were in the line of fire, the atmosphere would peel away and the surface sterilized instantly. Galactic collisions don't just kill life, they eject planets into deep space like cosmic bowling pins. But if galaxy-wide destruction isn't enough, what about a single star's corpse that can tear atoms apart? A magnetar is a neutron star with a magnetic field so strong it rips atoms apart. Step within a few thousand kilometers and electrons get yanked off atoms. Your body literally unravels at the atomic level. Even at safer distances, magnetars spit out bursts of gamma rays that could sterilize planets light years away. One pointed at Earth could strip the atmosphere and end life instantly. They don't just kill you, they erase the concept of you. But if a star corpse is this lethal, what about a black hole running a full-blown death concert? Quasars are supermassive black holes on feeding frenzies, swallowing gas and stars while blasting out more energy than entire galaxies. Get near one and radiation vaporizes you before you even register pain. Worse, quasars fire relativistic jets, cosmic death lasers that could strip Earth's atmosphere in seconds if we ever wandered into their crosshairs. They don't just end lives, they erase whole planets. But what happens if, instead of what they emit, you fall into the hole itself? A black hole is a collapsed star so dense that not even light escapes. At its edge is the event horizon, the ultimate do not cross sign. Fall toward a small one and tidal forces spaghettify you, feet and head stretched until you're pulled apart atom by atom. With a supermassive black hole, you might cross the horizon without feeling it, until every path leads inward to the singularity where physics breaks. From your view, you fall in. From an outsider's, you freeze at the edge forever. Romantic in the worst way possible. But before a black hole is born, the star's death scene is violent enough to vaporize worlds. A supernova is a massive star's final explosion, outshining galaxies and releasing in seconds more energy than our sun will in its entire life. Too close and you're vaporized instantly. Even 30 light years away, Earth could lose its ozone layer, leaving us fried by the sun. Radiation, crop failure, extinction, wrapped in starlight. And that's before the physical shockwave, which would shred planets like tissue paper, but even supernovae pale compared to the universe's ultimate sniper rifle. Gamma-ray bursts are the most powerful explosions we know, triggered when stars collapse into black holes or neutron stars collide. They fire jets of gamma radiation at nearly light speed, death beams that make supernovae look quaint. A direct hit vaporizes tissues, shreds DNA, and kills instantly. Even thousands of light years away, Earth could lose its ozone layer and face mass extinction. They're the universe's sniper shots, rare, precise, and utterly unforgiving. But while gamma ray bursts are sudden, there's one killer that doesn't explode. It waits. After all the explosions, the final killer is silence. The universe keeps expanding, stars burn out, black holes evaporate, and eventually every atom breaks down. Energy spreads so evenly there's no usable heat left. The cosmos becomes a frozen wasteland just above absolute zero, where nothing moves and nothing happens. No fire, no radiation, just entropy maxed out. It's not dramatic, it's simply time itself running out. After all the bullets, bursts, and black holes, the quiet fate of the universe is the last executioner.